Hello everyone, welcome again. Well, in this video we are going to discuss about steganography. So what is steganography? Steganography is a mechanism by which you can hide the data inside the digital medium. For example, consider this JavaScript as data, and this data can be hidden inside the digital medium with the help of steganography. So the most commonly used digital mediums are JPEG and BMP images. This represents two different formats of image, audio file and video file. But there is a basic rule which we need to follow in steganography. Whenever you hide the data inside the digital medium, that should not cause distortion in the property. For example, if I am hiding the data inside the image, that should not cause any change inside the resolution or the size of image. So in this video I am going to show you how you can hide the data inside the BMP image or bitmap images. So this is a sample bitmap image. As you can see here, the size of this image is 674 kilobyte and the resolution is 554 cross 415. So whenever I say image, every image consists of pixel, and pixels are responsible for giving color to the image. So if you look at this image, its resolution is 554 cross 415. That means the total pixel which are present inside this image will be 554 cross 415. That is width into height. So this number of pixel, total number of pixels are present inside this image. As I told you, pixels are responsible for giving color code to the image. So every pixel will give color to the image, and the pixels are usually represented in the form of three primary color, that is RGB, or in other words I can say that the color code is represented by these three primary color, that is red, green and blue. So every pixel will have these three components, and depend upon the intensity of each component, there will be a different color pixel. So the algorithm which we are using is called LSB, that is least significant bit. So in this algorithm, whatever the data which we have, first we'll convert that into the binary form, and we are going to override that data with the last bit of the pixel. So data will be at last bit of pixel. So let's say I'm using 24 bit of BMP image. So in this image, every pixel will be of 24 bit, and if I further break it down, so RGB, so for red color 8 bit, for green color 8 bit, and for blue color 8 bit. So this is how RGB will be represented inside the 24 bit BMP image. Now the format, or you can say the sequence of RGB inside BMP image will be RGB. So the last 8, you can say the least significant 8 bit will be blue color, and the most significant 8 bit will be red color. So for example, let's say I want to hide the data 1 inside this image. So first I will convert it into ASCII, that is ASCII value is 49, and this ASCII value will be converted into binary. So 49 can be represented as binary as 111001, and this will be encoded inside the pixel. So here every bit will be present at the last bit of your blue color, because here the sequence is RGB and we will hide only one bit at one pixel. So every bit of image will be present into the last bit of your blue color. So for hiding one character we need 8 pixel, because ASCII value is of 8 bit. Okay, so again summarize this algorithm. First we will convert our data into a binary form, and every bit of our data will be overlapped with the last bit of pixel. So for hiding one character we require 8 pixel, because the ASCII value will be converted needs 8 bit. Okay, so this is the image which I am going to use for hiding the data, and this is the data which I am going to hide. So I'll open my command prompt and I type the command java-jar, the jar file name, that is bmp stegno, provide the image file. So image file is our capture.bmp, and the data file, that is our testfile.txt. So this particular jar file is going to create a one more image with the encoded data. So as you can see here, there is a one more image which is created just now, and this contains the encoded data. The encoded data is this particular JavaScript. So if I open this particular image, so this is our original image and this is our image which contains the data. So as you can see here, if you look at both the image, you can't see any difference, but the second image contained the data, that is 601 characters inside it. So if I open this with paint, and this is the encrypted image. So as you can see that in the original image the size is 674 kilobyte and the resolution is 554 cross 415, and if you look at the image which contain our data, that is hidden data, its size is also 674 kilobyte and resolution is 554 cross 415. Okay, so there is no change in the original image and the image which contain the hidden data. So this is our original image and this is the image which contain the hidden data. Now in order to decrypt it, so I'll again call my jar file, and this time I'm going to supply the image file which contain the encrypted data. So it has created text file. So if I open this, and this is the data which we are trying to hide. So as you can see here, this is the entire data, 601 character, and here also 601 character. So this is the LSB algorithm for hiding the data inside the bitmap image, and if I give a one round of walkthrough to the code, so this is the method which is going to perform the operation. This method takes an array, integer array, which represent the pixel coming from the image, and the file input stream which will read the data present inside the file converted into binary format, and it will scan every character present inside the file and override the last bit of the pixel. And when it comes to decryption, again it will scan the image, pixel of image, and convert the data, or you can say only pick up the last bit of the pixel, that is the blue color last bit, and convert into the data which is hidden. So this source code I have already shared at the GitHub. You can download it from the GitHub, and the source code link is present in the description of this video. So that's all for this video, and thanks for watching.